Welcome to this video. My name is Phil and I am a senior lecturer in astrophysics at the University of Lincoln, and in this video I wanted to have a look at an unusual type of planet which is known as a lava world or a lava planet, and what they actually are and why they exist essentially. Well, the first thing to note is that these are typically going to be terrestrial planets, so they're going to be similar sort of sizes to our terrestrial planets like Mars, Earth, that sort of thing. But the difference here is that their surfaces are so hot that they are covered, or at least partially covered, in molten lava. So they'll actually have almost oceans of molten lava as opposed to water on these planets. And to give you an idea just how hot they actually are, their surface temperatures, on the left there you've basically got a red dwarf, or it could be even a red giant star, because they actually will be a similar sort of temperature, a similar sort of colour. One's just bigger than the other, but they can have temperatures around about 2 to 3,500 Kelvin. That's the surface temperature. Stars obviously are a lot hotter in their centre where they generate, or where the fusion is occurring, but their surface temperatures can be relatively low. And a lava world or lava planet can have surface temperatures almost up to 4,000 Kelvin. So they can actually have surface temperatures hotter than stars, which sounds a bit bizarre, but it's because of the way that stars generate their energy, and it's the surface temperature. So these are very hot planets. And this is actually a temperature map of a lava world or lava planet that has actually been created. So you've got the longitude, latitude position on there, and you can see that actually it's not an even distribution of temperature. And again, it goes up to just under 3,500 Kelvin at its hottest point, and even the lowest point, which is actually almost black here on the map, is still over 1,000 Kelvin. So it's still a very, very hot surface. Why is it uneven? Well, it has a day side and a night side. It's tidally locked. That means that one side of the planet always faces towards its star, so that side's always going to be much hotter than the night side, which is always facing away. So you have a large temperature difference here. If a planet wasn't tidally locked, then you'd expect a more even distribution of temperature around it. But here you've got a very hot side and a very cool side. And the interesting thing here from this temperature map and these observations that were made of this planet, it was thought, or they suspect, that molten lava is flowing from the hot side to the cool side, which is actually going to reduce the temperature difference, but you've actually got flowing lava on this particular planet. Now, why are they, or why do they even exist, is one reason. Well, they can be very close to their star. So one reason why they exist, why you get lava worlds, is that they will be very close to their star. So the actual or the radiation from the star is what heats the actual planet itself. And when I say very close to the star, it will be well within inside Mercury's orbit in comparison. So if you actually were to create a lava world in our own solar system, it would be a fraction of Mercury's orbit. So it'd be very, very close to its star. And these planets are going to be heated by the actual radiation from that star itself. And that's what's actually creating the very, very hot surface temperatures. Now, another reason why we might end up with a lava world or lava planet is from tidal heating. Now, if planets are very close to the star, they will actually, or they will end up being tidally locked. So they will end up, their rotation will slow down. That actually introduces heat into the planet because you get tides from that which deform the planet as it's rotating, a bit like the tides on Earth. The moon causes tides in the ocean, but actually if they're close enough and the tides are stronger, that deformation will be in the rock structure as well. So it kind of stretches the planet as it rotates. That causes an internal friction, which introduces heat, and it will slow down and become tidally locked. But also, if the orbit is elliptical, it will actually be tidally heated as well, because on an elliptical orbit, it will get closer to the star or the planet and then further away. And that basically means that when it's closer, those tides, the tidal forces will stretch it slightly, deform it, and then it moves further out. It will then relax back to a more spherical shape. That again introduces heat. So tidal heating can actually generate significant heat in an object. And an example is Jupiter's moon. So Jupiter's moon Io is probably the most volcanic object or body in the solar system. You've got a nice volcano there actually erupting from the surface, and that is mostly driven by tidal heating as it orbits Jupiter, basically. Now, another reason why you might end up with a lava world, and one that is actually more applicable to Earth, is giant collisions. So when the Earth and the Moon first formed, the early Earth collided with a young planet named Theia, which was kind of Martian size or the size of Mars. You then ended up with the Earth and the Moon, which then coalesced into what we have now. Now, at the point of that, that would have generated a significant amount of heat on the objects, and they would have been essentially lava worlds at that point of the giant collision. So, giant collisions can also create lava worlds. It could also be that it's a young terrestrial planet. So, very early on, as they're forming in these disks around stars, they slowly grow, say slowly, depend on the exact mechanism, but they will grow from smaller objects like asteroids, minor planets, even larger planets collide, or not necessarily larger planets, but kind of larger protoplanets. And that introduces heat into the planet. So if it's quite a young planet, it will still retain that heat from when it formed in the disk. So it could be that it's still quite young. Again, the Earth would have been a lava world due to collisions and things like that, or it could be that it's very close to its star. But either way, there are planets out there that are covered mostly by molten lava on the surface, which we will basically classify as a lava world. So thank you for watching, and if you enjoy, then do check out some of the other videos.